today we'll be doing the two-sum problem and showing how to get the general fastest solution. The task is to create a function that can search through an integer nums and basically find two numbers in the array that add up to a certain target that's also given. In this case, we can see that we are given this array with 2, 7, 11, and 15. And we get a target 9. And our program would be able to figure out that 2 and 7 add up to 9. And then we would just return the indices. So let's get right into it. So something I like to do when going through these problems is kind of think what a human would do when trying to solve this problem. Obviously, because the array is so small, if we know that we only need 9, we would see quite immediately that 2 and 7 are a match, and we would just say 2 and 7. But obviously, the array will get a lot bigger, and we're going to need more practical ideas. So let's just say our target was 26. So in this case, we won't obviously see right away that we have a combination over here. We would see that we have 11, 15 eventually if we're checking by adjacent ones, but that obviously doesn't make sense because there's no guarantee that the numbers would be adjacent. So one idea that will come to many beginners is to simply do a brute force method, in which we would first see 2, and then just look through every other number and see if that would make it work. In this case, none of them would work, as they're 9, 13, and 17. We would then continue the process to 7, in which we would get 9 again, 18, and 22. We would eventually continue this process until we finally got to 11, in which, after going through the array, I believe 12 times, we would get this solution. Now, the overall time complexity of this is quite logical. We know to go through the entire array would be n time, and because we would go through it as many times as this element, which would also be n, we would have like n times n, which equals n squared. That means that the overall time complexity will be O of n squared, but we do have constant space complexity because we actually don't have to store any elements in another container, which is a pro of this solution, but there is one that uses O of n time. And to kind of get to this solution, we need to kind of think of the why of our original solution. At first, we know we're just brute forcing every combination, but if you think about it, if we have a target 9, and we look at any number inside of here, in this case we'll look at 2, notice that there's only one other number in the array that can make it so they could add up to 9. In this case, we could do simple subtraction to see we need to find a 7. And when we need to find a number in an array, if we could use a set or a hash map, which would give us O of 1 read time. If you're familiar with the contains duplicate problem, this solution should be pretty intuitive for you. So one thing we could do is we could first search through the entire array and keep track of each number in the array so we can remember if it's there. But there's also a slight optimization we can make by using a hash map instead, because hash map, you can have a key and a value. So if I store the elements, I would also want to keep track of the indices, because remember, we're not returning the numbers, we're returning the indices. So I would just basically continue this process all the way down to 15. And then later I could search through it again. I would start at 2, and then I could search for 7. We would see that we have the index 1. So then we could finally return our current index and the one stored in the hash map, which was 1, and we would have a solution. Woohoo! And again, if you are familiar with the contains duplicate problem, there actually is a slight optimization we can make by only having to go through the array once. In this case, as we go through our array, we're actually going to be creating our hash map and checking. So we would start at 2 and we would search for 7 and actually an empty hash map. But afterwards, we're going to add 2 along with this index. Oh, wow. And then we're going to immediately go to 7, and then we're going to see that 2 is found, and then we could return, in this case, 1, 0. The order doesn't matter. It's the same solution we got earlier. You might be wondering, hey, what if we had like the other corresponding number a lot later? In this case, for 2, we don't know if there's a 7. So isn't it kind of bad to check an empty hash map? But in this case, that's actually wrong, because as we saw, each number only has one correspondent. So 2 corresponds to 7, 7 corresponds to 2, and you can see that they are the same. So by the time if we were to get to the match, we would actually go backwards and see that it was already in the hash map. So let's get into coding this in a simple Python solution just to get it all out, you know. So the first thing we would want to do is to initialize our empty hash map, which would contain all the numbers. So I'm going to give it a great name of numbers key values. I don't know. Make it kind of intuitive, whatever. And then we're going to iterate through each of the numbers by just referencing each number in the array. And the first thing we would want to check is for basically the corresponding numbers. So we know that would just be the target minus the number. For example, if the target is 9, we're currently looking at 2, we know the corresponding one is 7. And we want to check if the corresponding one is in our hash map or dictionary, so like what we would call in Python. They are very similar though, so you don't really need to worry about that. In this case, if we do, we need the index of our current number, and then we would also be checking the index here, which should make you realize that we actually need to keep track of the index. We would change this to just loop through by the length of the numbers and just say the current number is the one at the index. Not a big change. So all we would have to do is return a list with our current index I, and then the other index which came along with the corresponding number. Either way, we still need to add it to our hash map. So I would enter our current number as the key along with the index, along with the value being our index, in this case I. And this should be enough. The problem itself says that no matter what, there is a solution. So we don't have to keep track of that edge case. So this should work. So let's submit that. As you can see, we have a really fast solution that beats 73% of users. But more importantly, we have O of n time complexity, which is a lot faster than our original O of n squared, because no matter what, we would only have to go through the array once. I should mention that there is more space complexity, which contributes to more memory. This still beats 58% of other users, and if you were to analyze this complexity, it would be O of n. The other brute force solution I mentioned earlier would have been O of 1. But overall, this is the solution I believe you should familiarize yourself with. Anyways, if you learned something from this video and this helped you, please give me a thumbs up. Hopefully you subscribe for more. Like always, bye-bye.